All right, you guys, in our previous video, we talked about this property here if we want to verify inverses, okay? So if I give you two equations and I ask you whether or not they are inverses, both of these conditions need to be satisfied. So I'm going to have to compose the function inside of the inverse and the inverse inside of the function. Once I do both of those compositions, if I get back x for both of them, then yes, I have inverses, okay? So we're going to try that so that you guys can see that rule in action. Okay, so the first problem that we have, it says verify that the inverse of f of x equals 1 over x minus 1 is this. The inverse of x equals 1 over x plus 1. For what values of x is the function composed of the inverse equal to x? And for what values of x is the inverse composed of f of x equal x? Okay, so there are actually three parts of this problem. We're going to have to do two compositions, and then we're going to have to find the domains of each of them because they want to know for what values of x is this satisfied. Okay, so if I kind of laid out a roadmap for us, the first thing we're going to do, we are going to find out what the inverse f of x, see if that equals x. The second thing we're going to do is this. And then we're going to find their domains. Okay, all right, so let's do number one first. So number one says we're going to compose the function. We're going to do the inverse composed of the function. So that means everywhere there's an x in their supposed inverse, we're going to put f of x. Okay, so I'm going to write our inverse, which is 1 over x. I'm going to put parentheses there, plus 1, okay? Where the parentheses is, I'm going to put f of x, which is 1 over x plus 1, okay? We need to simplify this, okay? So this first part, we have 1 divided by 1 over x plus 1. Instead of dividing by a fraction, we can multiply by the reciprocal, keep change flip. So that's going to be 1 times x plus 1 over 1 plus 1. X plus 1 over 1 is just x plus 1 times 1 is just itself. So x plus 1. Oh, it's minus. Change this to a minus. Change this to a minus. There we go. Minus 1 plus 1. All right, and negative 1 plus 1, that's 0. So that equals x. So the first one worked out for us, okay? So let's try the second one, where we put the inverse inside of f of x. All right, so let me change black to a color. So number 2, I'm going to write f of x, 1 over, going to put parentheses where I want the other function to go, minus 1. And in that parentheses, I'm going to put that inverse. So 1 over x plus 1. And now I'm going to simplify. So in that denominator, I have 1 over x plus 1 minus 1. The 1's are going to cancel. So it's going to give me 1 over x. All right, instead of dividing by a fraction, I can multiply by the reciprocal. X divided by 1 is just x, and then times 1 is x. So I got both of those compositions came out to be x. So they are inverses, okay? They satisfied both of those conditions that we needed. And let's find the domain of each of those. See. Oops, not red. Okay, so let's find the domain of the first one. Okay, so if you guys remember when we were finding domains of composite functions, okay, we thought about them like filters. So for number 1, okay, the inner filter would be f of x because it's the inside function. And the outer function would be the composite function. Okay, so we need to look at f of x. So this is f of x. F of x is a rational function. It looks like a fraction. So that means you can plug in anything you want into that function as long as the denominator does not equal 0. So the denominator there is x minus 1. So if we set that equal to 0, add 1, x equals 1. So that means we can plug in anything we want into that function as long as x doesn't equal 1. Okay? And then we look at our final function. Well, our final function is x. X falls in the polynomial family. Okay? And we know that the domain for polynomials is all real numbers. You don't have to exclude anything. So the only value we had to be careful for is this one here, which is 1. So for the domain of this first one, okay, the domain is all numbers except for 1. So if I say brace all x such that x does not equal 1. Okay. All right, let's find the domain for the second one. So if we think about the filters again, okay, for the second one, the inverse is the inside function. So it's going to be our first filter. Okay, and the composite function is the second filter. All right, so our first function for this one, all right, is this guy here, okay, which is still a rational because our x is in the denominator, looks like a fraction. So we can choose anything we want as long as this denominator does not equal 0. The only value that's going to make that 0 is 0. So x cannot equal 0. And then we look at our final function, which is x again, and x falls into the polynomial family. So the first one was a rational. Okay, and we know that for polynomials, their domains are all real numbers, negative infinity to positive infinity. So the only value we have to exclude is 0. So for the second one, okay, our domain are all x such that x does not equal 0. Okay, so what this is telling us is that these two functions that they've given us, they are inverses as long as you fall in between these values of x, in between these domains. Okay, for those values of x, this will hold. Okay, I hope this makes sense.